I want to talk to you today about phasing transformers. I'm going to keep it really simple. Now, I had this video almost done, and Windows decided to load. Would you like to switch to Windows 11? Yeah, knocked me right out. Locked up my camera and everything. I'm just back to getting things back to where I was. So I get to do this video again. Now, this is a 1.5 volt battery. So is this. And you have to understand that both are 1.5 volts, but this has more capacity. If you were to use this in this guy's circuit, it would last longer, but there's more to it than that. If you were to put this in this guy's circuit, the 1.5 volts would drop right down. It doesn't have enough capacity, enough amperage. All right? You have to understand voltage and amperage. You have to understand there's two different things. And transformers. Here we go. 6.3 at 3 amps. At 6.3 volts at 3 amps, this thing will give you 6.3 volts at 3 amps. And without a load, it'll be a little higher. Now, 6.3 is, the meter will reach 6.3. 6.3 volts of DC and 6.3 volts of AC will light an incandescent bulb the exact same brightness. It wasn't a coincidence. 6.3, the meter is set up to read the equivalent of DC voltage. It's just the way it was because things were originally ran on batteries. Way back, they used batteries to run radios. And then later on, people got electricity in their house. So a guy would come once a week and change your batteries in your radio. I know it's hard for you to understand, but same as the ice man. He used to bring you a block of ice, and then later on you had a refrigerator that plugged in. All right? So when they come up with the convention, they were dealing mostly with resistive loads. So they figured out how to make the meter read the equivalent amount of wattage and heat and the whole thing. So Ohm's law would work for both AC and DC. That's another concept. All right, so why is this transformer 6.3 volts? All right, tubes. It's a filament transformer. It's made to light a 6.3 volt tube. Filament, not the high voltage, just the filament. So there, you will notice that there's transformers that are 6.3, 12.6, 9 volts, 6.3, 9 volts, and 12.6. And there are 24 volt ones. And they're all from the tube days, but they continued to sell these things, and everybody's project was made using a filament transformer. All right? So now, the trick with AC is it's the same as DC in a way. When you parallel a bunch of batteries, you have to put all the negatives together and all the positives together. Now, with AC, you just can't do, you can do that, but you have to understand phasing. Now, 110 goes into these wires here, and it's got a sine wave. Now, if you look at this, there's a left-hand wire, left-hand side, right-hand side. So you have to take the left-hand side wire and put it to the left-hand side wire. All right? We do that. I do it real quick. Make believe I did that if they fall apart. And then the right side. Now, these are phased, sort of. Now, you put them in front of each other. Remember, we're doing parallel. The right-hand side wire goes to the right-hand side wire. And the left-hand side yellow goes to the left-hand side yellow. I'll bring it over just to make you happy. All right? Now, when you plug it in, you get 6.3 volts, 6 amps. Now, if you got these two wires reversed, you'll have 0, and you'll hear a humming noise and maybe some smoke. All right? Now, that's parallel. Now, if you want to put them in series, remember, the primaries are tied together, left side to left side. Now, I'm going to explain a little bit more detail in a second. Then you would take the left, and the left would go to the, the right would go to the left over here. And then they're in series. Look at the cameras all freaking off. I'm over here. Look at this. I'm really being screwed over by a lot of things. Windows has gotten me pissed again. But anyway, that's phasing. You have to understand that. Now, in transformers, the real good ones sort of look like, all right, here's one here. And you look on the back and you'll see a dot. All right, this is the primary side, black wires. You'll see a dot like this. All right, a dot. Then on the opposite side, over here, I think it's catty corner, right? You'll see a dot over here. And that helps you wire it up quicker. If you got to wire 20 of these up in parallel, all the dot wires all go together to make one side of the AC. The other wires all go together on the other side. Then when you come over here and you want to hook the secondaries, you hook all the dot ones together. Now, I told you the story about Joe Turon. We had these submarine rectifier tubes, and they took 8 amps inrush current, maybe 10 at 6.3 or whatever, maybe 12. Like that submarine would be like 12. So anyway, I kept hearing them mumble to the boss, and they were talking like really low. And the boss is like, Joe, when are you going to do this? We got to get this done. And this went on a few times. And then finally I asked Joe, I said, Joe, what's going on? He goes, we have these tubes for submarines, and they charge the batteries for the submarine. And he goes, we have to hook them up. We need a lot of current for each tube under test. And I said, oh, you got to put transformers in parallel. He goes, yeah. He says, I can't get it to work. So we go down there, and I got my scope. I told you the story before. Got to do the Lissajous patterns, and I get down there, and he brings out the transformer, and it's 10 times bigger than this, right? And I see the dots. I said, Joe, those are phasing dots. Yeah, I know, but it's still not working. So I said, well, maybe we got 2 different brands of transformer. So I look, and it's all the same brand. So I look, and he's got them. They go to big. Each one of the transformers have a lug on the end of the wire, and it goes to a bus, a big copper bus. And I look, and it's wired right. So then I go to the primary side, and it's got a dot. And they're 50% this way, 50%. I said, Joe, you got to phase both sides of the transformer. And he just looks at me like that stunned look, like the deer in the headlights of the car. And he goes, oh, no. I go, yeah. So I said, the boss is circling us. And it got me annoyed. You know, I'm back there. I know how to do Lissajous patterns. I got the scope on. I'm giving it away for him because I know this guy don't know what a Lissajous pattern is. And he's going to leave us alone. And I got the vacuum cleaner out because he liked everything clean. And as we're cooking, I mean, I'm talking these big slabs of Bakelite with a bunch of transformers sitting on them, heavy as hell, 75 pounds easily. Lift them out, and I'm vacuuming, you know, and I hook up first one. Joe lights his pipe, and we're sitting there, and we got the scope, and we got the Lissajous pattern. Oh, by the way, I think when they're in phase, it's a circle. Anyway, I forget that, but anyway, they're all working. And I said, Joe, just check. These transformers are all wired. They're all humming. They're on. There's no load. But I said, keep checking to see if we get one that gets hot, just in case. But it was fine. He knew what he did wrong. And it all has to come down with phasing. So I explained to you that they use these weird voltages on transformers. A lot of them. 6.3, 9 volts, 12.6, and there is a 24 volt. And it's all about back in the old days. And when they made transformers, they kept making them the same voltages. So project builders had to work around that. Now, Radio Shack sold a power supply for a CB radio. And guys, the geniuses out there would blow it up. And they drill the case out. They had pop rivets. They drill it out. They changed the transformer to a 12.6. And then they'd bring it in and said, this ain't working right. I open it up and I'm like, where's the transformer from there? Oh, I burnt it out. It's pretty hard. It's fused, but he burnt it out. Because he blew the fuse, changed the fuse to a bigger one, then he blew the transformer out. Now he's put in an anemic little tiny transformer, and he's doing the same thing the guy I grew up with, but it's 12 volts, but it keeps going in the same circle. And I said, but it's not, doesn't have enough amperage. And people don't understand amperage. If you understand voltages, how they add up, but then you don't understand amperages, you're useless, you're lost, right? So I would say to these guys, this power supply it's junk now. I said, you know, that transformer can be fixed. And they just stare at me. They're all staring at me. So finally, someone brings one in, and he says, the fuse blew. I put a bigger one in. I said, did you change the transformer? No. I said, all right. So we drill it out. We drill out the pop rivets, open up. I take the transformer out. 2 more pop rivets. And right by the primary here, I hope all this is in the frame. Right here, you cut with a scissor. And in here is a piece of wire that's sitting in there. That's a fusible link, like in a car. And that's all you have to change to fix the Radio Shack power supply. And then you put the correct fuse in the fuse holder for the power supply. And that would fix it. But people would screw up. They go to pull the unit out. They would use the unit in the car and in the house. And they didn't put tape on the wires. The wires would touch. It would blow the fuse out. And then they wouldn't have the right fuse. They put a different fuse in. The next time the 2 wires hit together, they burn the transformer fused winding out, fusible link. And this is what I went through. And you just go around in these giant circles. But if you don't understand that amperage, okay, so we take enough of these batteries and we make 12 volts. Holy shit, where the hell's the freaking camera? All right, we take a bunch of these, we make 12 volts. It will not start the car. Right there. And I had a friend that he just stared at me with that stupid look. No, 12 volts is 12 volts. No, it's not. This battery, if you have enough of them, make 12 volts, it won't start the car. It doesn't have enough cranking power. It doesn't have enough amperage, voltage, and there's also amperage. And you could say capacity. And there's people that go through life only understanding voltage, sort of understanding voltage. And I get in these fights with these people. And, you know, then I learned what Mark Twain said. When you argue with an idiot, who's really the idiot? Now, I'm ranting a little bit. I'm really upset because I did the video really nice. And then I looked at my computer, and it was locked up. I was making sure I was in the frame, and this wasn't working. And behind it, I see Windows is telling me about Windows 11. Yeah, it locked my camera up. It stopped me from what I'm doing. This is like the I won't say 700. This is like the 100th time Windows has done something stupid like that. Norton decides to, I'll scan the computer for viruses and lock up a video on me. And I know one guy keeps telling me to get a laptop or something like that to use. You know, it's these programs. It's supposed to be multitasking, right? Why does it shut my camera down? But anyway, I wanted to explain to you phasing. All right, it's very easy. And the other way you can quickly phase is you wire these 2 transformers real quick, the primaries, with maybe I like to use wire nuts. You wire it all up. You put the wires on the output the way you think they go. And you put your meter on there, and you just put the plug in temporarily real quick and see what voltage you get. If you don't get, if you got them in series, if you don't get 12.6, you got your phasing. And you can do the phasing back here. You can fix it back here by just reversing the wires. And I could draw you the diagram and show you a sine wave and show you one that's upside down because it's out of phase. But if you put both the right-hand wire with the right-hand wire and the left-hand wire with the back here and then do the same thing there, it'll be in phase. All right, whether it's, this is different, this is serial, it would be different. But in other words, there's phasing involved. It's not just voltage. And these weird voltage values of 6.3, 12.6, 12.6, that's filament transformers from the tube days. And Radio Shack, right till the end, sold filament transformers. It's a sort of a standard. And they're like, well, I need 12 volts. It's not a 12-volt transformer. I got news for you. If you got a power supply and it's got a transformer in there and it's giving you 12 volts, that's a special transformer. Because when you rectify AC, if you rectify 12.6, you're going to get about 18 volts. Depending on if you use full wave or half wave. I don't want to go into that. But there's these tricks. There's tricks all over the place. And this is where beginners get screwed over. And you really have to understand. And all the tech school guys that I graduated with were clueless. And I get in arguments with them. And the teacher sometimes was wrong. Oh, man, some of the stuff he did. You know, the guy's fixing a record player. We're graduating. And the guy's got the record player. I think his name was Joe. And Joe's over there, and the teacher's got him running frequency sweeps of the amplifier. It's this little stereo record player. And he's running sweeps, frequency sweeps of both channels. And I walk over and go, what the hell are you doing? He goes, Miller's got me running frequency sweeps. And I'm like, for what? He goes, I have half volume on both channels. I'm going, is your power supply right? Yeah. I said, the cartridge is broke. And the teacher's looking at me like, what do you mean the cartridge is broke? All right, there's ceramic cartridges and there's magnetic cartridges. A ceramic cartridge, a Vodco, it was a Vodco. If you got a woman or an idiot operating a phonograph, they'll drop the head of the tone arm down on the record hard, and inside the 2 strips of piezoelectric crystal, it breaks in half, and you get half the voltage out. You have to have the volume. Now, I became an expert on taking them apart and repairing them because my mother and sister would continuously break the, and they, oh, I didn't do that. Yeah, you did. And I had extra cartridges, and I took them apart. There was a rivet, you drilled it out. You could actually go inside and replace the ceramic elements in there. But yeah, the teacher's got them doing frequency sweeps. So I said, Joe, drive me over to my house. It's like a mile and a half from Rest. We drive over there. My mother's home at lunch from work. And we're in there, and I'm taking the cartridge out of my record player. I said, yeah, I said, the teacher's being an idiot. So we go back, and he puts my cartridge in, same model, puts it in there, and he's blasting, he's pissing the teacher off. And I said, all right, now we're going to Berger. He had a car. Most of the students had cars. I didn't have a car. And we drove over to Berger Electronics, which was Bloomfield Avenue and Watsessing. And he went in. I told him how to talk to Berger. And even if he doesn't answer, he's like thinking. It's like, I won't say the soup Nazi, but similar. And then the guy went in the back. He brought out the exact model. We went back, and he put the phonograph worked. And then I got my piece of paper out, and I started drawing what's inside the cartridge. You know, if you want to drill it out, and it's a piece of rock, and I think it's quartz. It might be some type of quartz. It might even be man-made. But when you hit the rock or the element, it puts out voltage. It's that simple. A ceramic cartridge. That's all that's inside there. It's similar to those things you click to start the barbecue grill. Very similar to that. But I just wanted real quick to put the phasing in your mind, so when something goes wrong, you reverse the wires, and then now it works. And then you remember. You just got to remember about the phasing. But poor Joe, he had bank after bank of transformers, and he phased them all correctly, but he didn't realize you had to phase the primary. Funny stuff. I think that's it. All right, that's it. Is this still running? Oh, thank God.